Download this code from codegive.com, link in the description below. Failure cases in API Gateway using Java Spring Boot, a comprehensive tutorial. API gateways are crucial for modern microservice architectures, acting as a single entry point for clients to access backend services. However, robust gateway design necessitates careful handling of failure scenarios. This tutorial delves into common failure cases when using an API gateway with Java Spring Boot, providing detailed explanations and practical code examples. We'll focus on Spring Cloud Gateway, a popular choice for this purpose. 1. Service unavailable ***. This occurs when a backend service the gateway relies on is down or unresponsive. Handling this gracefully is paramount to prevent cascading failures and provide informative error responses to clients. Code example, Spring Cloud Gateway. This filter intercepts errors and checks if a backend service is down. Isbackendserviceunavailable needs to be customized based on your specific error handling needs. It currently checks for common connection refusal and 503 errors. The filter then returns a 503 response. 2. Rate limiting ***. Preventing abuse and ensuring fair access to your APIs requires rate limiting. If a client exceeds its allowed request rate, the gateway should reject further requests. Code example, Spring Cloud Gateway using Redis rate limiter. This setup uses Redis for efficient rate limiting. You will need to configure a Redis instance. The rate limit filter checks if a request is allowed based on the configured rate limit. If exceeded, it returns a 429 response. You'll need to modify the Lua script or add more logic to tailor the rejection behavior. 3. Authentication and authorization failures ***. Failing to authenticate a user or authorize access to a resource is another frequent issue. The gateway should reject unauthorized requests. Code example, Spring Security. Spring Security provides robust mechanisms for authentication and authorization. Integrate Spring Security with Spring Cloud Gateway to handle these failures. The basic setup is beyond the scope of this example, but here's a snippet illustrating how to respond to authentication failures. This configures Spring Security to require authentication for all requests. An authentication entry point is set to return a 401 unauthorized response upon authentication failure. You would typically use JWT or OAuth 2.0 for actual authentication mechanisms. 4. Timeout ***. Backend services might become slow or unresponsive, leading to timeouts. The gateway should handle this gracefully, preventing clients from waiting indefinitely. Code example, Spring Cloud Gateway. Spring Cloud Gateway's web client offers timeout settings. This sets a timeout for backend service calls to 2 seconds. A more robust solution might involve retries or circuit breakers, Hystrix, Resilience 4J, for more resilient handling of timeouts. 5. Circuit breaker failures ***. Circuit breakers prevent cascading failures by stopping requests to unresponsive backend services. When a circuit breaker is open, due to too many failures, the gateway should return an appropriate error response. Code example, Resilience 4J. Resilience 4J is a lightweight library for implementing circuit breakers. You wrap calls to backend services with circuit breaker.execute supplier. If the circuit breaker is open, an exception is thrown, which the gateway can handle to return a sensible error message, example service temporarily unavailable. Conclusion ***. Thorough error handling is essential for a reliable API gateway. This tutorial showcased several common failure scenarios and provided code examples demonstrating how to use Spring Cloud Gateway and related technologies to handle them gracefully. Remember to tailor the error handling logic to your specific needs and integrate appropriate monitoring and logging for proactive issue detection. Robust error handling enhances the overall resilience and user experience of your microservice architecture. Consider adding centralized logging and monitoring to track and analyze these failures in production.